The sequence programs can be either event-driven or time-driven programs. The sequencer chart lists the sequence of operation of the outputs. The corresponding sequencer file will contain the ones and zeros representing when the outputs will be on or off. Take a moment to get an idea of what the pattern of lights will look like. This simulation has the same pattern of ones and zeros with an additional step of all zeros for all of the outputs to be off. As the push button is pushed, the ones and zeros in the output table for O:2 and the lights will change according to the program sequence. A time-driven sequencer can have different time intervals for each step. In this example, for a traffic light for a four-way intersection, we are going to use one sequencer instruction to provide the pattern of lights for the red, yellow, and green traffic lights, and another sequencer to provide the preset time for the timer that controls when the sequencers will be incremented. The times will alternate between 25 and 5 seconds. Both of these sequencer instructions will increment on the done bit of T4:1, going from false to true. They both have the same control word address and the same length. The first sequencer moves data from file N7:0 to the destination O:2. This sequencer will control the red, yellow, and green lights of the traffic signal. The second sequencer will move data from file N7:10 to the preset of timer T4:1, controlling how long before the lights on the signal change to the next step. The preset of timer T4:1 is initially set up with a preset of 1/10 of a second. Almost immediately, the done bit of the timer is set and step 1 of the file N7:0 is moved to the outputs and step 1 of the file N7:1 is moved to the preset of the timer. Each time the done bit becomes true, the sequencers will move the next step in file N7:0 to the outputs and the next step in file N7:10 to the timer preset. After the fourth step, the sequencers will start over at step 1. This is an example of a time-driven sequencer with a constant 3-second time interval. When switch SW is closed, the timer will time for 3 seconds and reset to time again. The sequencer will output data from file B3:0 to the output O:2. The mask is FFFF, so all the bits will be transferred to the output. The binary table shows the data in file B3:0, which will be moved in sequence to the output O:2. We can now switch and look at the output table and the status of the outputs for O:2.